Hello class, welcome to SciChem. Here we are another session for lecture number 2 of surface chemistry. In the previous class, we have discussed about some basic concept about surface chemistry, that is physical adsorption, chemical adsorption, etc. Now we are going to discuss factors affecting adsorption of gas by solids. So what are the factors that affects adsorption of gas? What are the factors that affect adsorption of gas by solid? So first is nature of surface area of adsorbent. Nature of surface area of adsorbent. The same gas is adsorbed by a different solid at different extent even at the same temperature. Greater the surface area, greater is the volume of gas adsorbed. That is, more is the surface area, more amount of gas will be adsorbed. Simply, if I take a block of solid and for this case consider adsorption. If I break the block of solid into small part, then consider the adsorption, in which case the adsorption is more. If I break the solid into small part, then in this case the adsorption will be more. So greater is the surface area, greater will be the adsorption. Then come to next part. What are the nature of gas being adsorbed? What is the nature of gas? That means the easily liquefiable gas, that is NH3, HCl, Cl2, etc. These are easily liquefiable gas, and these gases can be adsorbed easily as compared to permanent gases like H2 or N2 or O2. These are not easily liquefiable gas. This each with each gas can be each gas can be liquefied depends on critical temperature. You have already studied in gases state critical temperature. More is the critical temperature, more is the critical temperature of the gas, more easily the gas can be liquefied. More is the critical temperature of the gas, more easily the gas can be liquefied. If I consider gas such as consider SO2, CH4, H2, and these gases have critical temperature 330 K, 190 K, 33 K. So if I consider sulfur dioxide have more critical temperature, sulfur dioxide have more critical temperature. So sulfur dioxide can be easily liquefied. So what is the nature of gas? Different gases are adsorbed to different extent even by the same solid. As the critical temperature of gas increases, it is easier to liquefy and it is also more readily absorbed. Reason: higher the critical temperature, the easier it is to liquefy the gas, as greater are the intermolecular force of attraction between the molecule of the gas. Higher the critical temperature, that is higher the critical temperature, the easier is to liquefy the gas, as greater are the intermolecular force of attraction between the molecules. For such gas, the intermolecular force of attraction greater on the surface of the adsorbent, and thus adsorption will be more. So the easily liquefiable gases can be easily adsorbed on the solid surface. Then come to next part. What are the effect of temperature on adsorption of gases? Since we are dealing with factors affecting adsorption gas by solid, this is one type of physical adsorption. Physical adsorption. So what is the effect of temperature? Since adsorption of gas on solid surface is a physical process, physical adsorption. So with increase in temperature, adsorption decreases. If I consider chemical process, then consider this graph. Two types of graphs are available here. X by m. X by m is degree of adsorption, which I will discuss later, but for this instant x by m consider degree of adsorption. So if I draw the graph between degree of adsorption and temperature for physical process, with increase in temperature the graph for physical process, physical adsorption decreases. With increase in temperature the physical adsorption decreases. The graph is just like here. Since with increase in temperature the graph, the curve, decrease in curve resulted. Next, if I plot the graph between x by m and temperature for chemical process, first chemical adsorption increases and then decreases. Come to this point is called saturation point. Why for chemical adsorption with increase in temperature chemical adsorption increases? The initial increase in chemisorption or chemical adsorption is because of activation energy required. In H there is a formation of bond. In chemical adsorption the activation energy required. This is why chemical adsorption is also called activated adsorption, which we have already discussed. Chemical adsorption are also called activated adsorption. So this is for physical or physisorption or chemisorption. This is for chemi and this is for physi. So with increase in temperature the adsorption decreases. Then come to next part. What is the effect of pressure? At constant temperature the adsorption of gas increases with increase in pressure. Similarly, if I draw the graph between x by m and pressure, graph result like this type of graph will be resulted. That means with increase in pressure the extent of absorption also increases. With increase in pressure the extent of absorption also increases. That is, the extent of adsorption of a gas per unit mass of adsorbent depends upon the pressure, and it is clear from the graph that extent of adsorption increases with pressure and become maximum corresponding to pressure. This is the maximum pressure, is also called saturation pressure, and after that the adsorption will remain constant. It will neither increases nor decreases. Adsorption will remain constant. Next, activation of solid adsorption. It means increase the adsorption power of the adsorbent, and it can be done by making the surface of adsorbent rough. It can be done by rubbing the surface or chemical action, and by dividing the adsorbent into smaller pieces. It is dividing the absorbent into smaller pieces. So what are the factors affecting adsorption gases by solid? First, the nature of gas, nature of surface area. More is the surface area, more is the adsorption. Next, nature of gas being adsorbed. Easily liquefiable gas can be easily liquefied. Easily liquefied gas can be easily adsorbed as compared to permanent gases such as hydrogen, oxygen and nitrogen, etc. Why? And most important point, higher the critical temperature, the gas can be easily liquefied. More is the critical temperature of the gas can be easily liquefied, because there is a more intermolecular force of attraction between the gases. That is the nature of gas. Next, come to temperature. Temperature, what is temperature? With increase in temperature, the gas adsorption of gas also increases, and you have to remember this type of graph. This is the graph for physisorption and this is the graph for chemisorption, where x by m, don't panic, I will teach you later. X by m is the degree of adsorption. Next, pressure. At constant temperature, the adsorption of gas increases with increase in pressure. This is the graph. We have to discuss this whole part again, so don't worry. Activation of the solid adsorbent, it means increasing adsorption power of the adsorbent. It can be done by rubbing, or by doing some by creating some rough area on the surface, or by dividing a particle into tiny particles or tiny units. We can easily increase the activation of solid adsorbent. So this is all about factors affecting adsorption of gas on solids. Next, the most important thing, that is extent of adsorption. Let us consider it is our adsorbent having mass m, and above which the adsorbent molecules are attached to adsorbent, and if x is the amount of adsorbed by m mass of adsorbent, then this is called extent of adsorption, or amount of adsorption can be represented by x by m, that is mass of gas adsorbed by m mass of adsorbent. So x is the amount of gas adsorbed by m mass of adsorbent. This is called extent of adsorption. So here x by m, where x is the amount of gas, m is the mass of the adsorbent. Next, come to next part. What are adsorption isotherm? The variation in the amount of gas adsorbed by the adsorbent at a constant temperature. Isotherm means constant temperature with a change in pressure is shown by a curve called adsorption isotherm. The variation of amount of gas adsorbed, that is x by m, which is also called degree of adsorption or degree of adsorption, or it can be renamed as extent of adsorption or amount of gas. So x by m can be renamed degree of adsorption, extent of adsorption or amount of gas adsorbed. If I plot a graph between x by m versus pressure at constant temperature, the graph resulted is called adsorption isotherm. So this is the graph, three types of graph. This is constant temperature 195, 244 K, and this is 273 and it have been found that with increase in temperature x by m increases, and it can be seen from the graph. That is, temperature, this is 273 K, this is 244 K, and this is 195 K. So extent of absorption is less for this 0 degree Celsius. 244 K is less than 0 degree Celsius and 195 K is also less than 0 degree Celsius. So if we increase the temperature, it have been found that x by m, or extent of adsorption or degree of adsorption, decreases. By observing such graph, a scientist named Freundlich in 1909 gave a relation. So what is Freundlich? Freundlich in 1909 gave a empirical relation between amount of gas adsorbed by a given mass of adsorbent. That is also same, x by m, amount of gas adsorbed by given mass of adsorbent. And he found a relation by observing this curve, this graph, and each curve. He gave a relation that x by m is equal to x by m is equal to k into 0 power 1 by n. This is the relation given by Freundlich by observing this graph. So x by m is equal to k into p raised power n, where x is amount of gas adsorbed, p is the pressure, where x is the amount of gas adsorbed per m mass, p is the pressure, k is constant, n is also constant, and it have value n should be greater than 1. If n is greater than 1, that means 1 by n is lying between 0 to 1. 1 by n lying between 0 to 1. So this curve indicates that this curve indicates that adsorption, this curve indicates that adsorption increases with increase in pressure at constant temperature. With increase in pressure, the adsorption also increases, but with increase in temperature, the adsorption decreases. With increase in temperature, the adsorption decreases. So how to calculate the value of K? We have the relation x by m is equal to k into 0 power by multiplying log on both sides. Log x by m is equal to log k into 0 power log x by m is equal to log k plus log 0 power 1, means log by m is equal to log k plus 1 by n log p. This is the simplified relation for Freundlich adsorption isotherm. If I draw the graph between log x by m, like here, log x by m and log p, is consider y is equal to c plus times. That means In y-axis I have taken log x by m, in x-axis write log p, where m is the slope 1 by n and c is the intercept. So the intercept will be log k and slope is 1 by n. By knowing slope, this is theta, tan theta equal to 1 by n. By knowing theta I can easily calculate n, and by knowing the intercept I can easily calculate k. Again, one of the important part is there. This, by observing one of the curve in this graph, there are three curves, but by observing one of the curve, it haven't found that with increase in pressure x by m increases. So here we have two cases. At very low temperature, very low pressure, at very low pressure I have x by m is directly proportional to p power k into p power 1 by n. At very low pressure n equal to 1, so there will be x by m directly proportional to, not k, p, x by m directly proportional to p. If x by m directly proportional to p, then the graph between x by m and p should be a straight line passing through origin. This is straight line passing through origin by m. So at very low pressure x by m directly proportional to p to the power 1 by n. For low pressure n equal to 1. If the n is equal to 1, then the graph looks like this. So x by m is equal to kp. For high pressure, the extent of adjustment will become independent of pressure. If I increase the pressure, the extent of adsorption will be independent of pressure. That means independent of pressure, that means x by m directly proportional to 0 power, means x by m is. So for high pressure, here this is the saturation point, saturation pressure. After this pressure, with increase in pressure, this will be independent of pressure. X by m is independent of pressure and it will remain constant. So x by m, degree of adsorption will remain constant after saturation pressure. At low pressure, x by m is equal to kp. At high pressure, x by m is equal to k into p to the power 0. At moderate pressure, x by m is equal to k into p to the power 1 by n. So this is the basic idea we can get from this graph that Friendlich already explained. Another part is there. If there are solution involved, the above equation becomes x by m is equal to k into 0 power 1 by n, where c is the concentration of solution. Next part is physical adsorption. Next part is physical adsorption. As physical adsorption is reversible in nature, I can write here adsorbent plus adsorbate plus adsorbate is right to adsorbent adsorbate. Here adsorbent is in solid phase, adsorbate are gas. Since for physical adsorption, this is the bond, weak van der Waal force of attraction. So if adsorbent and adsorbate, if adsorbent adsorbs the adsorbate or gases are adsorbed on solid surface, then this process is called condensation. Or if there is a break of bond between adsorbent and adsorbate, they will ultimately form adsorbent and adsorbate, then this is called evaporation. And since physical adsorption is a equilibrium reaction, that means rate of condensation is equal to rate of evaporation. So Langmuir considered this equilibrium and explained Fendlich adsorption isotherm. So what is Langmuir? Langmuir explains for physical adsorption. Langmuir considered adsorption of gas involves following two processes: adsorption of gas molecule on the surface of solid, first thing; desorption of the adsorbed molecule from the surface of solid. Desorption means evaporation. That means if the gas particle evaporates from the surface of solid. And he believed eventually a dynamic equilibrium is established between above two opposing processes, that is condensation and evaporation. So what he considered, since adsorption is a physical process and is equilibrium in nature, so what he considered, rate of condensation directly proportional to pressure. That means if I increase the pressure, the rate of adsorption also increases. Rate of condensation nothing but rate of adsorption. If I increase the pressure, rate of condensation also increases. Consider this is the surface. If I increase the pressure, the gas molecule easily adsorbed on solid surface. Again, rate of condensation is directly proportional to 1 minus theta. Now what is theta? Theta is fraction of covered area. Theta is fraction of covered area. That means this is the surface area and this is the area in which the gas molecules are absorbed, and this is the area in which the gas molecules are not absorbed. So this is the area, that is theta. And rate of adsorption depends upon the available adsorbed site, this site available. So here that is 1 minus theta. Sorry, rate of condensation, rate of adsorption, 1 minus theta. So I can combinedly write equation 2, rate of condensation directly proportional to P into theta, or rate of condensation RF is equal to K1 into K into. This is equation. Similarly, rate of evaporation, and rate of evaporation depends upon adsorbed site or theta, fraction of area covered by the gaseous molecule. Rate of evaporation directly proportional to theta. So RB is equal to K2 into theta. At equilibrium, RF is equal to RB, or K2 RF K1 P into 1 minus theta is equal to K2 theta. K1 P minus K1 theta equal to K2 theta. K1 P is equal to K2 theta plus K1 theta. P is equal to theta to K1 plus theta is equal to k1p divided by k1 plus 2. So theta is fraction of area covered, and this fraction of area covered, or theta, can write fraction of area covered. X by m degree of art, extent of directly proportional to theta, means by m directly proportional to theta, or in other words x by m is equal to k3, and theta we have calculated the value. X by m is equal to 3 into k1p divided by k1 plus k1 k3 p divided by k1 plus x by m is equal to k1 k3 p by k2 divided by k1 plus k2 2. It will be equal to by m is equal to k1 k3 by k2 p divided by 1 plus k1 by and x by m is equal to ap I made a small mistake. M is equal to plus k2. K1 p theta. So here k1 p theta plus k1 p minus k1 p theta. So k1 p is equal to k2 theta and k1 p is equal to common theta k2 plus, and theta is equal to k1 p by k2 plus So this is the value of theta, and theta is fraction of area covered, and x by m directly proportional to theta. So x by m is equal to k3 theta, and x by m is equal to k3 k1 p divided by k2 plus k1 p. Again, x by m is equal to k3 k1 p by k2 by k2 plus k1 p by k. I can solve this. By m is equal to k3 k1 p by k2 divided by 1 plus k1 by k2, and this I can write by m is equal to ap by plus, where b have value k1 k2 and a have value k3 k1 by k2 and b have value k1 by k2. Here I can write a here I can write A and B are two parameters. A and B are two parameters of Langmuir adsorption hydrothermal. So we have the equation x by m is equal to ap by plus bp. From this equation we can explain friendly charges on isotherm. How? Let at low pressure, when the pressure is very low, that means P tends to 0. If P tends to 0, then BP will be 0. So x by m is equal to AP. That means x by m low temperature. Here at low temperature, low pressure, at high pressure P tends to infinite. If P tends to infinite, I can write 1 by P tends to 0. If P tends to infinite, then 1 by P tends to 0. So this equation by m is equal to AP by 1 plus Bp. If I divide P on both sides, then x by m is equal to AP by P 1 by P. So 1 by T tends to 0. Pp cancel. X by m is equal to by. This means x by m is independent of pressure, so P power 2. So at low pressure x by m directly proportional to P, at high pressure x by m directly proportional to P power 0. So at moderate pressure I can simply write x by m directly proportional 0 power 1 by n. So from this equation I can easily deduce the explanation for Friendlich-Adjusson isotherm. So we have x by m is equal to AP by 1 plus BP. If I can reverse this equation, m by x is equal to 1 plus BP divided by AP, means simply I can write here B by A plus 1 by AP, means m by x is equal to B by A plus 1 by AP. Y is equal to mx. If I plot the graph between m by x 1 by p, this is equation of straight line. Type of graph will be resulted having intercept b by a. The slope will be a. So this is all about Langmuir-Adjusson isotherm. So we have discussed in this topic, it is Friendlich-Adjusson isotherm and Langmuir-Adjusson isotherm.